I'm Josh. I'm the co-founder at Astria. We're building the shared sequencer network. I'm not here today to talk about the shared sequencer network at all, but it is relevant to know that this is just kind of like this is a very selfish talk of mine. I am just talking about things in my head that bother me about this industry after 3.5 years working full time here. And fundamentally, the core thing is like I think we're building all the same thing, and we're all building the same same thing. What do I mean by that? We're all building kind of the same network topology, and like the core problem here is that we seem to be doing this, and people don't seem to be aware that we're doing this, and that is a problem. It's like very, very wasteful from a time perspective. It's like, why am I talking about this? Fundamentally, there's like a lot of reasons, and I had to like pick one to write, and like the talk is like me, but like, okay, here's your like nice answer of like why I'm talking about this. Fundamentally, if we all have a shared understanding or like a shared vocabulary, we can reduce the transaction cost when we coordinate across ecosystems. Something, make like a meta joke about like bridging and like, you know, state machines being more similar allows bridging to be easier. But fundamentally, if we are all using like the same language and have like a shared understanding of like what other ecosystems are doing, we can probably solve some of the difficult problems in just designing blockchains, right? To Crisco's point, like we've done a little bit of work kind of designing distributed databases. We don't need to be doing this work in a different manner in the Celestia ecosystem, in the Ethereum ecosystem, in the Solana ecosystem. A lot of these problems are like very, very similar. One thing I will also preface this talk with, I'm going to be talking about everyone else's systems, not my systems. I am going to be a little bit wrong probably about all of these, and there is someone in this room that is an expert on at least like one of these things. I don't think I am like catastrophically wrong to the point where like what I'm trying to get across is like not useful. The kind of main takeaway I kind of want out of this talk, ideally everyone has maybe a little more understanding of how one other ecosystem that they are not primarily working in works, and they can have some useful kind of correlation between some component from their ecosystem they understand and some component from another ecosystem that they now have some understanding of. Most of these things are open source. The code is kind of available. People do a relatively good job about documenting what they're working on. If we are able to understand each other's work, we have a much larger amount of like prior art to work from, and we can probably like reinvent the wheel a little bit less. A lot of other reasons that like it's just like bothered, like stop inventing new jargon, please. Stop calling the thing that was something last year a new thing this year. Okay. This is the not nice answer to why am I doing this. We should stop gaslighting each other. That is not a good use of time. It makes us look like children to the outside world. I don't tell people that I talk to outside of crypto that I like work in crypto. I'm like, I do some distributed systems research thing because we have a reputation, again, Crisco's talked about, and you know, Barry also talked about, right? Like we have a limited amount of like credibility as like an industry. We should at least try to maintain that credibility within the sphere of our own industry and not try to like harass someone because they're like 5 steps away on Solana instead of on Ethereum. Same people relative to like the larger world. Okay, so why blockchains? Like why are we doing the blockchain thing at all? We're using blockchains for censorship-resistant settlement, and those are like large words. What do those mean, right? I always go back to this quote from Nick Carter. I think this is like the best, like, you know, kind of like short definition we had of like, what did we mean when we say settlement, right? And it's like settlement assurances refer to a system's ability to grant recipients confidence that an inbound transaction will not be reversed. And I'm not going to dig too deep on like this slide, but like there are like various like important words, right? Like inbound transaction will not be reversed. It's going to assume the talk's going to go into like an inbound transaction is not necessarily like sufficient. You need to get the transaction in the block. That's a bit of what I'm going to be talking about. But what is censorship resistance? That is actually like a much harder thing to define in like a useful manner. And so I guess what I'll go with is anyone can land a transaction at the market rate, right? Because the idea, if you like simplify it too much and say like, oh, anyone can get a transaction included, there's like a fundamental reality of like the blockchains have fees because they need to have some metering mechanism to like prevent spam transactions getting in, right? Like Zano talked about how like Solana may be at like too low of like a base fee and therefore they get a lot of spam, but you have to have some idea of a market rate. You know, I'll note like anyone, that's like a pretty broad term. Market rate, also a pretty broad term. You know, again, as like Zano mentioned, I'm gonna borrow from like everyone else's talks again, trying to borrow context from others. Determining the market rate, like what do you submit as like a bid transaction on Solana, seems like a little more art than science right now, right? A little bit hand-wavy. But this is what I'll work with for like censorship resistance, and we'll go back to the settlement assurance guarantee, right? Like irreversibility of a transaction, right? I'm going to talk about kind of two phases of like when people say like, include a transaction or whatever, right? From like a settlement insurance definition. The user wants to get a transaction to the block producer, right? I'm going to assume we are all in the leader-based consensus kind of protocol world here, where the relevant thing to get your transaction included in a block is that it has to somehow get to the block producer and therefore included in the block for the next time or the next n times or whatever, right? We also, are going to briefly touch on like the block producer getting the block to the rest of the network, right? So, what happens once the block producer says, hey, I have signed on this, I now need to get it to the rest of the network, I need to get consensus on it. But by and large, we're going to be focused on user getting a transaction to the block producer and similarities across different ecosystems. And I guess when I say get to a block producer, again, we're going to assume they also want it to be included. We don't just want the block producer to see it, right? So we're going to start with like quality of service. And what is quality of service? So I just pulled this off of like, this is like a paraphrase thing off of Wikipedia for like quality of service. And we're using this quality of service in the way that like Solana uses it, and the way that like Google uses it, and the way that like general like networks use like quality of service. We're not saying like customer service. Fundamentally, it is a quality of service is the ability to provide different priorities to different applications, users, or data flows, or to guarantee a certain level of performance to a data flow, right? So fundamentally, this is the ability to segment kind of your, service into some set of tiers, right? And so if we want to use like a, go back to like a George Orwell thing, right? All the animals are equal, but some animals are more equals than others, right? And the relevant point, right, again, we went back to anyone can land a transaction, right? Well, some people are going to have an easier time to land a transaction. We're going to talk about the different ways on different networks where there are ways to get higher priority to land a transaction. But again, the point of this talk is we're doing very similar things, and my argument is we're doing those similar things because that is how networks work at scale. Just kind of understanding that that is a like broad, just like baseline thing, and it's not like, oh, that's because Solana is built this way. That's because Comet BFT runs this way. That's because Ethereum runs it. No, that's just how networks work. You have to kind of pick some level of kind of segmentation of QoS at scale. Otherwise, you have other trade-offs, right? I'm going to talk about 5 like general like ecosystems. So I'll talk about Ethereum. I'll talk about Arbitrum very briefly. I'll talk about Solana. Talk about the interchange. We're not trying to call it Cosmos. We're canceling Cosmos. And I'm going to talk very, very briefly about like Google, and I'm using Google, one, because like I used to work at Google, but also because Google actually has a very good open source SRE book that goes into some of the kind of like principles for how they run their networks and how they kind of suggest to other people if they want to become an SRE, a DevOps, whatever, that they can do that, right? So starting with Ethereum, right? Why do we have PBS in Ethereum, right? Again, this is like other people know much more about this than me, but I'm not wholly ignorant of this. PBS, for those that somehow don't know and are in this room, proposer-builder separation, right? This is, again, Xano, Jito, and the Solana version of this, right, is separation of like block building from like the block producer. You're outsourcing this to some trusted third-party auctioneer, right? But why do we fundamentally have PBS in Ethereum? It's because we had priority gas auctions, right, prior to MEV-Geth. This is like maybe my argument, a little bit before my time, but fundamentally people wanted to get transactions in, they wanted to get these searcher transactions in, they wanted to do arbitrage. The only mechanism they had to do that was to spam a bunch of transactions on chain, and that led to these priority gas auctions where you'd have over the block time just an increasing cost to include a transaction. And essentially, this was just pricing out like normal people, right? Like I think it was like Chris Guzray had said, it's unclear, like, and getting less clear over time, like, is a user a human, is a user a bot, whatever. But we'll use like a high-level thing of user. But you have people spamming priority transactions, right, to do arbitrage, and those people are causing kind of like second-order negative impacts on like the price to include a transaction for people that are not doing arbitrage, right? And so we've done PBS for that, right? So let's look at like the MEV supply chain. Like, thank you, Stefan. I'm like borrowing like a lot of your stuff from like the original like MEV Boost blog post here, right? This is like a very simplified diagram of how like the MEV supply chain works, right? So we're going to see a user submits to a builder. We're just going to assume the searchers and the builder are the same thing because they kind of are now. And the flow really is the user is going to submit a transaction like to a builder, right? Somehow, right? Maybe it goes through like the wallet and the RPC or whatever. But somehow a user is going to get a transaction to the builder. The builder is going to send that block, right? The builder is going to be the entity that builds the block. They're going to submit that to the relay, right? And the relay is this trusted third-party entity. The relay is then going to send it to the proposer, right? And they're going to have technically going to send like the header to the proposer, right? They're going to get the proposer to sign the header and come back, right? Now the relay and the proposer are kind of like on terms, right? And they have like a guarantee, right, that they've seen each other. And then the relay is actually going to be the one that gets it to Ethereum, right? And this is like a relevant point. I think I probably like probably should have included a slide on like how this works in like a not this case, right? But I think the general assumption, right, when we talk about the two phases of transaction, you have a user getting the transaction to the block proposer, and the core thing here, right, is the user is going through the builder and then the relay, and that's how they get to the proposer, right? And then when we actually think about how the proposer is getting the block to the rest of the Ethereum network, they're actually also going through the relay. And so like the core thing to take away from the slide, if the relay goes away, none of this shit works, right? The relay is the most important thing. It's like other things we're not going to run on. The relays are not incentivized. The relays are like relatively expensive to run. I've heard quotes from $100,000 a year to $500,000 a year. There's like 4 or 5 relays, so you guys should talk to each other. If some of you are running these things for $100,000 a year and some of you are running for like $500,000 a year, there's clearly, you guys should at least be like meeting in the middle there and not paying 5x more. But that's the kind of takeaway, right? It's like the relay is like this important entity. It is expensive to run. There's not many of them. It's like a centralized component. It's trusted. It's not paid. The other big thing is like the relay is a big box. And what I mean by that is just like the relay has the ability to handle a large amount of like bandwidth, throughput, whatever, right? Like a lot of people are talking to the relay, right? So that's the takeaway from here, right? We'll go through some quick definition. Probably should add the other slide. Builder is the person specialized in the construction of Ethereum execution payloads using transactions received from users and searchers, right? And so this is just the PBS core thing, right? The builder is going to be the person who receives the transactions or the bundles or whatever, right? It's going to produce the actual like block, right? So there is a separation of like construction of a block and inclusion of a block. Fundamentally, being included in a block has like a two-phase aspect to it, right, in Ethereum. You, as like a user, have to create a transaction and like pay sufficient that the builder is willing to include it in their block. But there is also this next step, right, of the proposer, who is actually the entity that is signing the block, right? And the proposer and the builder are being intermediated again by the relay, right? The core thing from this definition, right, and again, these are like Stefan's definitions from like MevBoost. It is a party specialized in DOS protection and networking who validates and routes execution payloads to proposers. And so again, we see it as this centralized component in between all the other boxes and focus on like the specialized in DOS protection, right? Why do we have the blockchain fees for the DOS protection? Fundamentally, there's like just like a disappointing reality you get in kind of like software engineering at scale when you realize like the fundamental reality of like DOS prevention is you have like a bigger box than like the guy trying to DOS you. That's just like how the world works, right? Otherwise, there's not a lot of cleverness around it. But like the relay is the big box, right? And so like, again, one of the things that I'm hoping you kind of take away, a lot of us are like trending towards making like a big box somewhere because we're all trying to scale and we're like, God damn it, we need like a large box somewhere, right? That doesn't work well with the running the validator node on the $1,000 laptop thing, but that's where we're going to, right? So simplifying the flow, right? User has to get a transaction to a block builder, relay gets the block to the proposer, and then relay gets the block to the network as well, right? Let's talk about Arbitrum here, right? And I'm not trying to like pick on Arbitrum. They just had like the most like explicit kind of example that like makes my point really easy here. This is like from Arbitrum's docs on like how Arbitrum does like block production, right? And so the core thing to kind of take away here is that the transactions on like top left are coming from users, right? And they are going to the sequencer, right? And then the sequencer is kind of responsible for like all the other stuff, right? We have like these various phases, but like from like a number of boxes, it's really the users talk to the sequencer, right? And that's kind of like the end of it, right? You know, I want to be like honest to like the roll-up architecture, right? We do have like an L1 delayed inbox on Arbitrum and like the other roll-ups, right? And this is just again taken from like Arbitrum's docs. It says, you know, even if the sequencer never includes our transaction in a batch, the client can include it in the L2 by posting to the delayed inbox, which is on the L1, and the fourth inclusion will happen after some delay period, but it's 24 hours. When we talk about like anyone can land a transaction, right, in a block, right? You can say, yeah, you can get a transaction in, but like 24 hours later, it's not great. So I'm going to assume that we are really, when we think about like the roll-ups right now, yeah, you have like a forced transaction inclusion, but it's not like good. So we're going to assume that like the sequencer is kind of like the core component. The sequencer goes away, like no one's going to use the roll-up, like no one's going to use Arbitrum. It's like, you can only submit it through the L1 and we just run Arbitrum on a 24-hour delay, right? Then we're going to talk about PR 1504, right? And this is add a relay client connection nonce, right? And that's like a PR title, right? That's an engineering title. What this actually meant to the community, right? Thoughts on Arbitrum's proposal to score connections by proof of work, right? This was the thing where you did basically nonce mining. I'm not going to go into too many details because I have to cover like 4 other ecosystems or whatever, 3 other. But essentially this was saying like, Arbitrum was saying, we have a big box. We have one big box. It does all the things. It's a sequencer box. People learned that there is one big box, and what they did was they spammed the hell out of that box. And then Arbitrum was like, okay, we don't want people to spam the hell out of the box. So then we refer back to like QoS. How do we stop people from like spamming the box? Well, fundamentally, you have to make some kind of tiering system for which transactions you're going to drop or which transactions you're going to prioritize, right? The way they initially proposed, right, and just again, I'm not like, trying to shit on Arbitrum too heavy here, like they didn't like implement this, right? They like kind of like, they realized their error, and actually, they were nice if they like participated in like a roast, right? Like that was great. But they had to kind of solve this QoS problem because they realized they were just getting spammed, right? I actually don't know, and this would be useful if people find me in the hall. I actually don't know how Arbitrum like resolved this. This problem went away because they didn't implement this, but like it seems to be like people aren't complaining about like Arbitrum being spam. That's now Solana's issue. But fundamentally, right, they had to do a QoS thing, and they tried to do this like proof of work because they have a box and they're like, how do I separate traffic, right? And if you go look at like Cloudflare, it's like a good doc on like what is a DDoS, how do you like deal with DDoS, and a lot of these examples fundamentally apply much better to like the like Web 2 non-crypto world than like the crypto world, where crypto very specifically is like choosing to have like pseudonymous identities, right? Like, Sybil is like kind of like an assumption of the territory. You're not uniquely identifying users unless you're WorldCoin, and like I'm assuming they're not in this room, right? But fundamentally, right, you can't separate like one user is one user. So, the mechanisms of saying, oh, that's real traffic and that's fake traffic doesn't really work in blockchains. And so you try to do kind of heuristic things, but just saying, that is like an indicator of like a problem. We saw a similar thing on Ethereum. How did Ethereum solve it? Ethereum created like an auction mechanism, and again, not going to focus on like microeconomics and like our auctions, like a welfare maximizing mechanism here, right? But generally, they just accepted the like, fine, whoever pays the most gets included in the transaction, right? And that has caused a whole lot of drama, and various people are upset about it. Maybe most notably, like Arbitrum doesn't like that idea. But fundamentally, you have to do something about QoS because people are just going to spam you if there is an incentive to spam you, right? Now let's talk about Solana, right? Speaking of spam. Solana has no mempool, right? That's kind of like one of like the core differentiations when you think about transaction and like block propagation and whatever in Solana. Again, everything I say here is probably like a little bit wrong. Like go talk to like Xano if you want to like actually know how Solana works. This doesn't have anything on like Jito. This is just kind of pulling from like their public docs, right? But this is roughly like, Solana. You have a client, user, whatever. They're going to submit a transaction like an RPC server. Solana for like a long time, right, has had like a relatively like core distinction between like an RPC server and a validator server, right? And that's simply because like Solana running at scale knew that like, okay, I'm going to run this on like a box or something. I want, whatever, my like 1 gig line to be used for my RPC server and like my other 1 gig line to use on like voting, and those are different boxes. So I'll separate those, right? So we've long had kind of that separation in Solana land. The RPC server is going to, instead of having a mempool, again, ignoring all of like how Jito works and stuff, right? Which apparently is like 80%. So this is like not that relevant, but it's just going to send the transaction to like the next like n leaders. I think it's like the next 3 or 4 leaders, and that's going to be like the 12 or 16 next slots or whatever, right? To try to get your transaction in, right? But then what we had is, right, we had a lot of spam in like Solana over the last, it's been like 4 weeks now or something like that, maybe more than that. And so they did this thing called like stake-weighted QoS, right? And this is like an optional feature, but like, this was one of their proposed features, and very similar to like Arbitrum, right? They say, we're getting spammed, how are we going to resolve this? Well, the way you resolve this in like normal networking is you do like a QoS thing. You say some traffic is more important than others, right? Some of the animals are more equal than the other animals, right? You have to kind of pick one, right? Well, you're a proof-of-stake blockchain. What's a good way to do it? You can do stake-weighted POS, right? So this is like the full, like, from Solana's like website on like their docs on like stake-weighted QoS. Here is just like, I swear to God, I didn't add words. I just like deleted some of the words to shorten it, right? But you can say stake-weighted QoS allows block producers to prioritize transactions proxied through a staked validator, right? So fundamentally what this says is, you are a validator, you have whatever stake, you want to get it to like the leader. The leader is going to maintain some list, not of, just at the block production time, right? Like a lot of these like stake-weighted like leader election mechanisms say you get a % of blocks that you get to produce yourself based on your stake weight. Okay, we now push that closer kind of towards the, again, like no mempool, but towards that like transaction submission but not block production stage of the thing, where we said, well, now actually even getting a transaction kind of in the visibility of the leader, not just you being the one who gets the right to produce the block, but even getting it to that is also going to be dependent on how much stake your validator has, right? And the thing that's actually great, right, about like the Solana people, right, they're very open about like what they're doing, like how they're building things. Explicitly on this site, they say, who is going to benefit from stake-weighted POS? And they're like, centralized RPC providers who provide this as like a commercial activity, they are going to benefit, right? Centralized exchanges who also run validators and have high stake are going to benefit. And again, I'm not like criticizing them. I'm saying that's what happened, right? You had a problem of people were spamming. You have to figure out some way of what what are you going to filter and what are you not going to filter? And they said, we're going to do by stake weight, right? And this is like how Solana block propagation works. Again, like Jito had like a, much better kind of presentation on how this works. So I'll kind of like punt to that, right? But like generally, right, we have like shred, we have block propagation, whatever, right? Somewhat, irrelevant maybe to like this discussion, right? Let's talk about Cosmos, but actually we're calling Cosmos the interchain now. So we'll talk about like the interchain. Fundamentally, I think everyone who's in the interchain space is going to agree that like high throughput networking in Cosmos interchain, this is just like an unsolved problem, right? We're looking at a lot of things, but it's not good. It's pretty easy. If you want to go today and get like a big Amazon box, you can probably DOS like, I don't know, like half the Cosmos chains out there right now, like without that much effort. Please don't do that. But like there's like videos and guides and like Twitter threads. You can go talk to like Gadikian, like there is information on how you can DOS these networks and like it's not that hard. So generally it's like an unsolved problem, right? The best we've got right in like Cosmos that we've been running for quite a while, right? I think it was like Jack Zampolin that proposed like the Sentry node architecture in like 2018. Again, this is just like a very like normal way you run networks in like a normal, like I have to run like a web server, right? You have a validator. The validator, very similar to Solana, right? You have the validator separated from the RPC thing, right? So you have a user. The user is not connecting directly to the validator. The validator has these sentries. These are essentially reverse proxies, caches, whatever, right? You just put an intermediary that says, I am committing more bandwidth, more resources prior to the transaction in my validator. The other advantage that, like, the interchain has is, like, generally these Comet BFT chains cap at, like, what, like 175, like 200 validators, right? So we have a relatively small consensus set, and that means that basically everyone running a validator within, like, a Comet BFT chain is like a professionalized actor, and thus going to them and saying, no, you don't have to just run like whatever, like, Cosmos key start, Gaia D start, and like run Comet BFT. It's okay to go to them and say, you have to actually set up like a multi like component architecture in your cloud or on-prem or bare metal or whatever, and these people are sophisticated enough to say, okay, great, we can do that, right? So that's kind of how we're doing that, right? Again, unsolved problem, I am not providing the solution. I'm not like providing any solutions in this talk. Let's look at Google, right? Roughly, this is like, from the SRE book, this is like roughly, again, like Shumo, I'm probably a little bit wrong here. I think you've been closer there more recently. But fundamentally, right, if you're trying to do it like a thing at Google, you got to get to a database, right? We can kind of think about in a very abstract way, getting to the database is producing a block or getting the block into the consensus. You're a user, what are you going to do? You're going to go hit a Google DNS server, right? And that DNS server is going to go tell you where the actual like Google front end, and the Google front end is a very interesting thing. It is a very large box. Like when I say large box, like when I was there, it's like 4 years ago now, they were like 4 terabytes of RAM thing, and they were just a buffer. And all they do is you send a packet to them, and they have a static list that they have loaded, and they say, I get packets that look like this, and I hand them to that guy, and they do nothing else, right? And so when we talk about like DOS prevention needing larger boxes, Google has a lot of the largest boxes. They have like 256 of these things. There's probably like 500 of them now, right? But the interesting thing, right, is like, where does the Google DNS server know where the GFE is, right? Well, you still have this thing, right? It's like a load balancer in the middle. This like GSLB, I can't remember what that stands for, but it's like a Google service load balancer, something like that, right? The core thing to take away from this slide is not like, oh, this is how Google works, and I know I'm like over time here, but there's a box, and it's in the middle of all the other boxes, right? And so if we go forward and we look at the diagrams here, we have users on the top left, and we have a box in the middle, and that box in the middle, all the other boxes have to talk to. And this is really like the core thing I want you to take away from this talk. We are all building our different ecosystems here, right? We're building Solana, we're building, the interchain, we're building, Ethereum, we're building rollups on Ethereum, whatever. Google has built a networking architecture that seems to work at quite a bit of scale. The architecture they've decided on happens to have a box in the middle. The architecture that the Ethereum people have decided on happens to have a large box in the middle. Maybe we should accept that, like, networks at scale happen to have a large box in the middle, and that is like a useful reality for like when we think about designing these systems, because we're all kind of converging here from like different sides of the thing. And if you just say, well, okay, damn, how are the other people that like aren't doing the blockchain thing like doing this at scale? That's how they're doing it at scale. They wrote a book. Astria, I get one shill slide. We also have 6 boxes, right? That's like the only relevant thing. We also have 6 boxes. That's the core alpha there, right? We thought about this up ahead, and when we designed our system, we made sure we had the same number of boxes, right? Here's referencing. This is a QR code. It can bring you a Notion doc. It's just like 45 or 50 different like links to all the blog posts and forum posts and whatever. So anyway, I'm Josh. Thank you, everyone, for your time.